Hi, my name is Emily and I'm from the Delaware Museum of Natural History, and today we are going to be learning about objects in motion. Before we start our activity, I want to go over 3 terms with you to help you understand a little bit better what we're going to be talking about. So the first term we're going to go over is mass, and mass is the amount of stuff or matter that's in an object. So what could help with this is the word mass comes from the Greek word massa, which means a lump of dough. So I have some Play-Doh here, okay? You can think of this as a little ball of mass. Now, denser objects have more stuff in them, or more mass. So if I were to make this dough more condensed with more stuff, it would have more mass. The second term I want to go over with you is called gravity. And you might have heard of gravity before. And it's a force that pulls 2 objects together. So the more mass an object has, the stronger its gravitational pull will be. So for example, let's say I have a lemon, right? And I let it go from my hand. What happens to the lemon? It falls, right? It will fall to the ground because the earth, which we live on, its gravitational pull is stronger than this lemon's pull. And so this lemon has a lot less mass than the earth does. And therefore it has a weaker gravitational pull. The third term I want to introduce to you is called orbit. So you might have heard of planets orbiting around the sun. The sun is a huge ball of mass, and therefore gravitational pull is so strong that the planets are all pulled into moving around the sun. However, the planets have their own gravity, and so they pull away from the sun. That's why we're stuck orbiting around the sun and aren't pulled directly into it. For today's experiment, we're going to use a couple different items. We're going to use a sling, a wooden rod, and some Play-Doh. So the first thing I'm going to do for this activity is to make 2 balls of Play-Doh that are evenly sized. So they should be the same amount of mass. Then what I'm going to do is I'm going to stick one of these Play-Doh balls on each end of my rod, like so. Then I'm going to hold up my sling, and I'm going to try to find the balancing point for the rod to make it even. And this might take a few minutes. Okay, so this is my balancing point. And now what I'm going to do is just slightly push one of the balls and see what happens. So the center where my sling is what you would call the barycenter, or the center of mass. And you can see how the 2 objects, since they're the same mass, are the same distance away from that center. Pretty cool. Now what I'm going to do is I'm going to try to make one ball bigger than the other, just to see how it changes the motion of the objects. It's not working in the center anymore, so I'm going to have to adjust. What do you notice about the center of mass? Which object is it closer to? bigger one or the smaller one? Right, it's closer to the bigger one. So now I'm going to try spinning the rod again. Now we're going to try to explore ratios. So we're going to make Play-Doh balls the size of what actual planets would be to each other. So the first one I made was Earth. Okay, so Earth's mass is 100 to 1 with the moon. So I used a fancy schmancy kitchen scale to measure out the mass of each of my balls. So this moon is 1 gram on my scale, and this ball is 100 grams. Now what I'm going to do is put them on my contraption. So if you looked at a picture in space, the objects would look similar to this in terms of size. Now let's find where the very center is within the Earth. So after a lot of trying, this is the closest I could get it to being level. So this is the Earth again, this is the moon, and we're going to see how the moon orbits around Earth.